It sounds fascinating. They are supposed to have had another Big Bang in addition to the one that created our visible universe with the well-known Big Bang. And now scientists have presented a new study that challenges the previous standard cosmological model. It is this second Big Bang that led to the creation of a dark parallel universe, our dark matter and dark energy dimension. Now, what does this mean for our cosmology, and are we now finally finding the real universe? Researchers Catherine Fries and Martin Wolfgang Winkler brought the study Dark Matter and Gravitational Waves from a Dark Big Bang to the world. Fascinating idea that also provides completely new ideas for the origins of the universe and the nature of dark matter. This study proposes that in addition to the well-known Big Bang, which is considered to be the beginning of the universe, another event could have taken place. All dark matter came into the world through a dark Big Bang. The linchpin of this revolutionary new theory is primordial nucleosynthesis, or Big Bang nucleosynthesis. It is the process that happened in very first minutes after Big Bang on Earth when our universe was very close to being the same as to Adam and Evil. In their study, Fries and Winkler found evidence that immediately after this primordial nucleosynthesis, another significant event took place that other scientists have so far overlooked: birth of the dark universe. Finally, this hypothetical event would be the long-awaited explanation for the creation and existence of dark matter. However, this mysterious substance will make up a large part of the mass in the universe but cannot be observed directly, not even with our best technological capabilities, because it does not produce or reflect light and doesn't emit measurable radiation. Therefore, it is a phantasm of the universe and of science. But it wasn't until I started studying gravitational lensing that I began to wonder, what if? What if we could one day perceive or measure it, and then discover a complete dark universe, parallel and coexisting with our visible world, a second Big Bang, mere light years away? Martin Wolfgang Winkler and Catherine Fries are astrophysicists at the University of Texas at Austin, and they both work closely with the Oscar Klein Center for Cosmoparticle Physics at Stockholm University in Sweden. To understand fully what is contained in their concept for the dark Big Bang, we need to get a feel for the idea in terms of the conventional Big Bang. Today, the Big Bang is the most commonly held scientific model for the creation of our cosmos and the trauma to the first universe. Unlike a true bang or explosion, however, the Big Bang wasn't really a bang in the normal sense of the word. Instead, a process of a sudden expansion where the universe was expanding from a single tiny point as an extremely hot and dense plasma, and then expanding ever since. It all started at 13.8 billion years ago. In the moment after the Big Bang, the universe was hot, dense, and matter and energy were one. The universe kept on expanding and cooling, and quarks, electrons, and all the basic building blocks of matter were born. Within a microsecond of the Big Bang, quarks then came together to make protons and neutrons. A few minutes later, the primordial nucleosynthesis that made up the first light atomic nuclei occurred, and was then left to age, well, at least over the next few minutes, if not slower than that. For about 380,000 years, it's said that the universe was like this, very dense and far from cool. However, the high energy and density confined free electrons and photons in plasma. Once that had cooled off enough, electrons and nuclei could have combined to form neutral atoms, a process called reionization, today known as the moment the universe became transparent. Since then, light has been free to travel through the cosmos, and we recognize today the remnant of this event as the cosmic microwave background radiation. The Big Bang does a great coherent job of explaining general expansion of the universe, the formation of the first elements, and the distribution of galaxies in the universe. However, yet many questions remained unanswered. Perhaps the biggest question carried was, how was dark matter and dark energy, the stuff that's about 95% of the universe, actually created? Now it's the dark Big Bang. The theory starts with the beginning of the inflating the cosmos straight away after the classical Big Bang. This phase could have been very important, and during which a hypothetical particle called an inflaton, one with immense energy and negative pressure, could have been involved. The original building blocks were inflaton that decayed into ordinary matter and radiation, and dark matter might have been a third. The second dark Big Bang followed this decay about 10 to the power of 35 seconds after the first Big Bang. What sounds simple at first had monumental consequences. Fries and her colleague Winkler speculate in their study that not just one dark matter particle was created, but several, some of which could be incredibly massive, up to 10 to the power of 19 electron volts, about 10 billion times heavier than a proton. Opening completely new horizons in astrophysics is the idea of massive dark matter particles. Yet another aspect of the two scientists' work is the asymmetry of the dark Big Bang. That could have made it produce more dark matter than anti-dark matter, a possibility that has the universe with more matter than antimatter. The solution to another great mystery of cosmology would have been found in the thesis. The validity of the previously standard cosmological model, is put to test by the study. While the work does not shake up the Big Bang itself, essentially the birth of the universe, it instead offers a completely new perspective on the history and structure of the universe. According to Fries and Winkler, massive dark matter particles could also produce gravitational waves that future experiments like the Laser Interferometer Space Antenna will be able to detect. If this is true, we would have a method of watching and studying interactions between dark and mundane matter for the very first time. This hypothesis of the dark Big Bang is an exciting one and can finally get us on the long-awaited trail of this mysterious matter. Many unsolved mysteries of the universe could be solved by dark matter, including the question of why there may be life. Mysterious substance discovered. You don't know that the dark matter discovery took place in the 1930s. However, when the physicist and astronomer Fritz Zwicky looked at the Coma galaxy cluster, which itself is over 300 million light-years from us, something very astonishing turned up. At the time, the laws of mutual attraction of visible matter were far from sufficient to keep the galaxy cluster together. At those speeds, there had to be another mysterious force involved in doing this. After Zwicky, he postulated that further matter is present which is not visible, but is stabilizing the galaxy cluster in its gravity. Zwicky shocked his colleagues at the time, and his ideas about invisible or dark matter were furiously rejected. But in the 1960s, astronomer Vera Rubin made another discovery that did not fit into the cosmic picture at all, and this was to change abruptly. In spiral galaxies, the density is much higher nearer to the center than farther away. By the usual laws of motion dynamics in the universe, the orbital velocities of the stars should be decreasing towards the outer regions. But Rubin saw something else and realized there must be some additional matter in the galaxies that isn't visible at first glance. Now, most physicists agree that this previously undiscovered form of matter must exist throughout the cosmos. Despite this, what this dark matter is actually made from remains unknown. Thanks to cosmological models, it's quite possible to calculate pretty much exactly which elements came from the Big Bang. Researchers Catherine Fries and Martin Wolfgang Winkler adapted their new idea of the dark Big Bang to this scheme. In elementary particle physics, axions, barely massed particles that interact via the electromagnetic force as well as gravity, were an indication of dark matter. Studies at the Large Hadron Collider in Geneva found this. The universe, they say, is expanding faster and faster, contrary to scientists' expectations, thanks to the energy of galaxies there that is driving the universe apart, an invisible force. And when we say on its head, this discovery completely turns on its head how we understand the cosmos. This has led to a complete reassessment of the theories of how the universe has expanded. The Big Bang created the universe around 15 to 20 billion years ago, and the universe is expanding ever onwards. For many years, scientists thought that the gravity of matter inside the universe slowed the expansion down. However, observations of distant galaxies and supernovae in the 1990s revealed something unexpected. The universe is actually expanding at increasing speed, otherwise known as accelerating. Physicists had to show it to explain this phenomenon, and that involved speaking of dark energy, a previously unknown form of energy that counteracts gravity to speed the expansion of the cosmos. Now it is entirely possible to integrate dark energy into Einstein's equations of general relativity. When Einstein introduced the cosmological constant to describe a static universe, it was originally introduced. But he later rejected the idea, after observing the universe expanding. Today, the cosmological constant is used in modified form to explain the accelerated expansion of the universe. Even so, the problem of dark energy is similar in its mystery to that of dark matter. Another theory, therefore, is it has to do with the vacuum energy of space, which, being deeply quantum mechanical, creates and destroys particles all the time as dictated by quantum field theory. On the other hand, measured values for the vacuum energy were found to differ strongly from theoretically calculated ones. Scientists are coming up against their limits when it comes to the vacuum in space. They can't just wander into space to see what's going on there. All considerations have to be experimental. Once, Albert Einstein said that the vacuum in space had to be a massive energy store, one whose true nature we hadn't yet discovered. In addition, scientists are beginning to look at alternative theories, including perhaps dark energy that changes with time. In this case, what is exciting is that some effects in space that previously had only been explained in terms of dark matter or dark energy can also be explained in alternative ways. The modified Newtonian dynamics, MOND, is a theory of gravity on the cosmic scale that simply changes the laws of gravity everywhere. But it's crazy, and maybe dark matter and dark energy don't exist, which would make dark Big Bang impossible. The Euclid Space Telescope was launched by ESA in November 2023. In an unprecedented operation, Euclid will scan and image the entire visible sky. The mission's clear aim is to find dark matter. If you've read this far, did you want to see a lot more exciting videos? Then subscribe now.